Good morning, my name is Rudra Krishna. Today I am going to explain about the work done and its various form. So basically what is work? As we know that in lower classes we learn the work is nothing but a product of force and displacement, but in general work done is nothing but it is a application of force which produces a displacement in a body. So here I can explain work done with a small example. Let us consider a body A which moves to the point A dash. So here we can say that the body undergoes a change in displacement, and let F be a force acting in some direction, and let alpha be an angle between the force and displacement. So generally, as we know, W is equal to F into S, but here since we are getting an angle between force and displacement, so we can write that work done by the body dW, that is dW is equal to F into dx into cos alpha. And by rearranging this equation, we can also write it as dW is equal to F into dx, where F is a force vector and dx is a displacement vector. So let us consider one more example. Let us consider a graph and point S1 and S2. A body moves from point S1 to S2, and F be a force acting in some direction, and alpha be a angle between force and displacement. So here we can say the work done by a body from moving from one point to another, we can say as integral of S2 by S1 F cos alpha into ds. This was the work done by a body. So let us consider the case of the work done by a variable force. What is work done by a variable force? It is nothing but a situation in which force of a body keeps on varying, but it maintains a constant direction. So let us take a small example again. Here we can say that f of 1 comma f of so we can say here that work done by moving from point x2 to x1, we can say integral of x2 x1 f dx. Under the graph we can also say it is a work done is equal to force into change in displacement, that is delta s, and f is a force vector. We can also tell the work done as area under shaded graph. So in different cases, for example, a body has a varying force and all as well as varying direction, we can use the formula du by dx is equal to 0. As we see here, du by dx is equal to 0. In vectorial form, if a body covers if a force acts in all three directions x, y, z, and the displacement change in displacement in also in x, y, z direction, in vectorial form we can write force vector as fx I cap, fy j cap, and fz k cap. As we know, this is a vectorial form, and change in displacement, that is ds, we can write a dx I cap plus dy j cap plus dz j cap. As we know the formula, work done is equal to f integral of fx dx. We'll get the by simplifying that we'll get this formula. Now let us consider the work done by gravity. So work done by gravity, basically let us take an example. A body moves from point 1 to point 2, and let's give the name to that point y1 and y2. So work done from point 1 to 2, we can integral of y2 and y1 fgy. So basically, since the body is acting downwards and the gravitation force is also acting downwards, so we can write f is equal to, as we know, f is equal to mg. So we can take integral of y2 y1 minus mg dy, that is dy is equal to change in position from point 1 to point 2. So we can write also we can also write this as minus mg y2 minus y1. We can also write this form as minus mg by y2 minus y1. Thus work only depends